Welcome to A-Level Product Design. My name is Mr. Richards and I am the Head of Design and Technology at St. Margaret's Academy. I believe that product design is really important for human existence. As individuals, we interact with thousands and thousands of products, and as a species, we are incredibly gifted at designing and making products that solve everyday problems and improve our lives. Just think of the wide variety of products you interact with within a week. The chair you may be sat on, the device that you are watching this presentation on, the clothes that you wear, the house that you live in, the furniture inside it, even the toothbrush that you brush your teeth with. Millions and millions of products designed and used by us. Product design is an engaging and creative subject that will help you understand the materials and the processes used to create a wide variety of products. We will help you gain the skills to use industry standard computer-aided design packages and computer-aided manufacturing machines, as well as traditional design and making techniques, to be able to design high-quality products and be proud of them. You'll also learn some of the softer skills that are really important for wider life and employment. Things like being able to work in a team, being able to analyse tasks, planning projects, and evaluating your performance. So I believe that product design at St. Margaret's is a good course for anybody who wants to be involved in the creative or technical industries in the future. I'll now attempt to explain more of the course in the remaining of this presentation, but I hope you will consider taking design technology at St. Margaret's, because I believe it is a great place to study.
Let me take you through some of the basics about A-Level product design. The entry requirements for the course are Grade 5 in GCSE Design and Technology, or a Grade 5 in GCSE Electronics, or a merit grade in a relevant Level 2 qualification, for example, the BTEC Level 2 in Engineering. But perhaps you didn't take those qualifications, and if so, then you could also access the course if you gain both Grade 6 in GCSE Art and a Grade 5 in Maths, or a Grade 5 in Physics, or a Grade 5/5 in GCSE Science. The teachers for the course are Mr. Jones and myself, Mr. Richards. It will depend on the timetable exactly what split of lessons there will be, but I would take the majority of the A-Level lessons. The exam board is AQA. 50% of the overall grade comes from a substantial piece of coursework or non-examinable assessment, and the remaining 50% comes from examinations that you take at the end of the 2 years of study. So let's break that down a little further. Exam paper 1 tests your knowledge of technical principles of product design and is worth 30% of the overall qualification, whilst paper 2 is shorter at 1.5 hours long and tests your understanding of designing and making principles. Paper 2 is worth 20% of the overall qualification. The non-examinable assessment, or coursework as it was known, is a complete design and make assignment of a substantial nature, and that is worth 50% of the overall qualification. Paper 1 tests your knowledge of the technical principles of product design. These are quite wide-ranging, and this paper includes material areas such as different categories of woods, metals, polymers, composite materials and smart materials. It looks at how they are made and what they can be used for, and what are their stock forms. We will investigate all of the relevant manufacturing processes involved in using those materials to make products. We look at different scales of production, the use of robotics and computerization to improve production rates and to create flexible manufacturing systems. The subject matter is interesting and broad and will equip students to understand how the vast majority of products are made. The content for paper 1 will be taught mostly across year 12. The delivery of the theory lessons is interwoven with practical work and projects so that the students can experience in a practical way how the materials can be worked with and to produce items. We put the theory into practice. The second paper is about the design and making principles of product design. This is more about why we design products the way we do, why they need to perform well, how the shape and form of the products may be determined by the technology used or because of how they need to be used by human beings. We investigate different design styles and philosophies. We answer questions like what makes a design iconic. We will critically analyse products that are considered to be classics, like the Eames lounge chair or the E-Type Jaguar. This second paper has very interesting content, and it helps students understand why humans enjoy living in a designed world. We investigate what are the needs of human beings, basic needs like food, shelter, but then up to why we make things feel valuable. And we look at how products can satisfy those needs. Most of the content is taught in the second year. There is a huge overlap between the content of this exam and the coursework that you will produce. So by producing the coursework, you will also help you be ready for the examination. Students will need to produce a substantial piece of coursework, or NEA, that shows their designing and making skills, and which is worth 50% of the overall grade. The coursework is marked by teaching staff and then moderated by the exam boards. This NEA is started towards the end of Year 12 and will continue into Year 13. It will take many hours of work to complete, but it is a really enjoyable experience. It is your opportunity to design and make a product of your choosing. You are not told what you have to design, and every student can design something different. You identify a problem and then design and make a solution. This could be based on your personal interests. You may, for example, be into sport. Tennis maybe, and you may wish to design a product for your tennis club. You may have a job, perhaps working in a cafe, and you could design a new coffee table that suits the cafe. You may know someone with a disability, and you want to design a product that would assist them. The possibilities are vast. The sense of achievement when a student has designed and made a bespoke item that solves a specific problem is immense. But there are other significant benefits to the coursework. It is 50% of your overall grade. So half of your overall grade can be achieved before the end of the 2 years. This means that your overall grade is not wholly determined by exams at the end of the 2 years. To me, that's a massive advantage, as you are not entirely relying on performing very well on one day for the exam. Another benefit is that you can use the project work as a portfolio when applying for university or apprenticeships. You can show people what you can do rather than just tell them what you can do. We prepare you for the NEA throughout Year 12. You will complete a series of mini practical tasks to build your skill and knowledge of materials and processes. You will also complete a shortened down version of the NEA, so you understand how to create a successful PowerPoint that records all of your hard work and your design decisions. Part of this training will include learning how to use computer-aided packages and computer-aided manufacturing machines. Here we can see a couple of current Year 12 students using a CAD package called SolidWorks to design an Art Deco mirror. We can see the CAD package, you're able to spin the items round and view them in an exploded view, or apply renders to them to make them look more realistic. This is an industry standard package. Just by learning this type of skill, you could equip yourself for jobs in the future. The next few slides show an example of some Year 13 coursework. The student in this case wanted to design a table that would be the focal point in the lobby of a high quality hotel. He wanted the design to ask the viewer questions, mainly, how does the table do that? He wanted to design an elegant table that looked like it might fall over, but because it's been designed in a clever way, it would still be very stable. And so he settled on a cantilever style of coffee table. You'll see that there's some modelling work done in foam board and then some modelling done in SolidWorks, so the computer-aided design package. He then records all of his decisions and the making process and made a high quality artifact at the end. The Design and Technology department at St Margaret's Academy is very well equipped. It's probably one of the best equipped departments in the city. We have several rooms, including our own ICT suite and electronics room. We have a significant amount of machinery, several large CNC machines. We also have a breadth of knowledge as a staff, so we have engineers and professional designers who teach the courses. We also have additional STEM type projects, so STEM is science, technology, engineering, maths. One of those projects is our Green Power Cars project. So we purchased 2 electric powered cars, and the students are able to work on those cars as part of the projects if they identify a problem that they want to solve. You'll see a video explaining a bit more about this on the next slide.
The Goblin car will be used to demo STEM to children in primary schools, while our bigger Formula 24 car will actually be used in green power racing events. This chassis cost £1,800, but we've already noticed it does have some major drawbacks. First and foremost, it is incredibly heavy, and this will certainly slow down the car. Plus, the tyres suffer from rolling resistance and hysteresis, which is a bulging at the bottom that causes energy loss in the tyres. We're also looking at creating a very aerodynamic shell to counteract the issues, and it should, in theory at least, provide some extra performance on the Formula 24 car. Speaking of aerodynamics, we've already designed some bodies in our wind tunnel that we built in STEM Club, and we've already investigated laminar and turbulent flow on the bodies. Laminar flow is where the air sticks to the car as it flows past it, and turbulent flow, or eddies, are where the air is moved away from the car and causes drag, which will slow down the car and reduce performance.
What interested me in product design was my fascination with how products are designed and made, as well as what steps are took for a product to become commercially successful, just to name a few. What I've enjoyed about studying product design is that it's a very different environment to being in a classroom. As well, obviously you will be in a classroom, you'll also be in the workshop for a lot of your time, where Mr. Richards will be teaching you all the vital skills that you need to succeed in the subject, but also succeed further down the line if you choose to take the subject further, like in university for example. The workshops themselves are some of the most well equipped and best in the city, every tool that you need at your disposal, which is a huge benefit when making your final product during your NEA. The teachers themselves are two of the most helpful and great teachers I've ever encountered throughout my time at St Margaret's since year 7. They are both easily accessible, with Mr. Richards in his office at the top floor of DT most of the time, with his door always open for anyone, and Mr. Jones usually in DT department as well, normally in the workshops. Product design itself is a really useful subject, as hopefully I'll be studying business and management in university next year, and product design has helped me as you also learn the business side of product making, such as product methods like mass and batch production, which will be helpful for me to go further in education. I would honestly recommend this subject to everyone, as you get great life skills whilst also having fun along the way.
Hi, my name's Nathan. I'm a year 13 student at St Margaret's and I study product design. And I studied product design mainly because I enjoyed it at GCSE and just wanted to carry it on. And I personally prefer doing more practical subjects, and over the course of the 2 years when we've actually been in school, we've had plenty of opportunities to do more practical based work just as much as we have done the theory. So in year 12 we did a small project over a couple of months where we made an Art Deco style mirror, which involved using different wood joints and knockdown fittings, but also helped us to prepare for the coursework, because we did a mini PowerPoint and alongside of it, which was just like a mini version of the coursework. But in the project we also learned about the theory stuff, so with knockdown fittings, wood joints, design styles, but also with design work like traditional design methods, and we got to do some software stuff with 2D design and SolidWorks. So there's a real balance between and great range of everything that you learn from drawing and design to the practical work to using software to the ins and outs of the industry, and obviously the technical side for the theory for the exam. And also the teaching and the environment in the classroom is great. This doesn't feel like there's this teacher-student hierarchy. Everyone kind of feels like they're on the same level. You can have a laugh with each other, which all just really helps to establish just a nicer and more enjoyable environment to work and learn in. The department's really well equipped. There's a good amount of workshops, tools, machinery, everything, the materials that you need, everything that you need, when it comes to actually doing your coursework. Because obviously you get to choose what you make and the project that you decide to go down to direct. So there's very rarely ever any limitation onto what you can actually make in the end because of everything you have access to. Also accessing teachers when you need help with something or you need to ask a question. Obviously when you're at home you can just email them and they respond very quickly. But also when you're in school and you need to ask a question or you need help with something, you just go to the department. There's basically all the time just at least one teacher who can either help you or point you in the direction of who you need to speak to. And overall I think from DT, I think if I could say one thing that I've learned aside from that would help me outside of the subject is the problem solving skills that you get from it, because especially in the coursework you direct very much your own project. You come up with the problem, you have to come up with ideas and ways to solve this problem, but even when you come up with a design you have to work around design issues, and a lot of that isn't just helpful in the subject but also outside of it in kind of life as well and in other subjects that you may do. And I'm hopefully going to be studying animation at Bristol in September, and obviously DT has helped with that in terms of all the design work and the drawing work, but also with the software. Those skills should hopefully help me when I get to go on to do that degree in September, so that should help me. And I'd recommend the course at St Margaret's, not only because the academic side of it is great and all the resources and everything that you have access to, but the teachers are great as well, and it's just a really enjoyable and it's a really enjoyable subject and a relaxed environment to be in. And it's not all revision based either. There's a really good balance of revision and the practical work and the theory side of everything as well. And
There are a wide range of careers to pursue after taking product design, and depending on what you couple your product design A-level with, there can be even wider range. If you take courses which are related to STEM, so science, technology, engineering and maths, in general the earning potential is high and employability is strong. So this is a really worthwhile course for you to pursue, and it leads on to lots of rewarding and quite lucrative careers. If you have any questions about the course, then you can contact me using the email address below.